All right, hello, and welcome to this video, which is all about finding the intercepts. You can see from our goal, finding the intercepts um, of a graph. So from a graph and of an equation when it's in standard form. So finding the x-intercept and the y-intercept, and that's what we're going to be talking about. So let's start by introducing what intercepts actually are, so we can talk about them. First of all, the x-intercept, I have a little diagram here, a little picture that kind of helps you take a look at it, and I'll label it so that you remember this is the x-axis of a coordinate plane, and this is the y-axis. The x goes across, and the y goes up and down. So if we're looking for the x-intercept, the word intercept kind of means where it crosses. So that's right here. It's where it crosses the x-axis. It's where the graph of that line crosses the x-axis, and that's exactly what our definition here is. So it says the coordinate where a graph intersects the x-axis. So wherever your graph is, wherever it intersects the x-axis, that is called the x-intercept. And then I'm guessing you can use some deductive reasoning and figure out that the y-intercept then is simply the coordinate where a graph intersects the y-axis. So it would be right here. Um, and remember, a coordinate pair, when we're talking about a coordinate, it has an x value and it has a y value, and it's inside parentheses like that. So we're going to actually look for those coordinates today from looking at, first of all, a graph, and then looking at equations. And we're actually going to find them without even having the graph. But that'll help us to then graph the line. All right, so the first thing I want to do, and I really, taking a look at these four graphs, what I really want to do is just find the x-intercepts, first of all. So it says find the x-intercepts of each graph. Now remember, the x-intercepts cross the x-axis. So for instance, graph A crosses the x-axis right there, and that looks like it's point. So you do the x first, so it's over 1, 2, 3, 4, and it's not up or down any, so that's 4, 0. That's what that point is. So if you're asking for the x-intercept, you're looking for the x-intercept, it's going to be the point 4, 0 on this one. If we look at graph B, looks like it crosses the x-axis over on the left side here. It doesn't look like it exactly crosses at an intersection, but we're going to approximate and say that would be, it goes over to the left 3, so that's negative 3. And then it goes up or down 0, so it's right on that line, negative 3, 0 would be the x-intercept there. So if you want to take a look at graphs C and D, and if you want to pause it for a sec, just kind of think of what you think the x-intercept of each one would be. All right, I hope you found those. If you're looking at graph C, it crosses the x-axis way over here. And that would be at the point negative 6, 0. And just a reminder, make sure you have these order pairs in parentheses. Otherwise, it's just two numbers with a comma. If it's in parentheses like that, that shows that it's an ordered pair of x and y. And then graph D, is it not right here? That's not the x-intercept. The x-intercept is way over here, crosses the x-axis there at point 8, 0. Now, there's one thing I wanted you to notice from all four of these. If you just look at the four, what do you notice? Well, this one is 4, 0. This one is negative 3, 0, negative 6, 0, and 8, 0. Well, I'm looking at them, and I'm seeing that they all have 0 for that y value. The y value is always the second value. Tells you if you go up or down at all. And these, you don't go up or down at all, so they all have the same, or I mean, the y value is always 0. And that makes sense, right? If you look at it, if you want it to cross the x-axis where it's actually on that x-axis, if it's on the x-axis, it's not going up or down any. It's just right on the line, in which so the y value would be 0. It just depends on where it is going across, so that would be the x value that changes. So then let's look at try and figure out some y-intercepts. Now I want to take a look, find the y-intercepts of each graph instead of the x-intercepts. And if you look back, y-intercepts are the coordinate where the graph intersects the y-axis, so that up and down axis. So if you would like to pause this for a second and take a look and try to find the y-intercepts for each of these, that'd be super awesome. All right, so I'm going to use green for this one. Hopefully you took a look at those. I'm going to use green to show where the y-intercepts are. So it looks like it crosses the y-axis up here. This one is up there as well. This one is actually in the negatives, and this one is up back in the positives. Starting up here, that would be, you don't go over at all, so it'd be 0, and 1, 2, 3, up 3. So that's our point 0, 3. This one is actually the same point, 0, 3. Down in graph C, looks like it's 0 over negative 3, so it's down 3. And then graph D, it's actually right there already, so that would be 0, 4. Okay, so we've got our y-intercepts just from the graph. And I want you to take a look and think what is in common between these four. So anything we can conclude about any y-intercepts? Well, the first thing that I noticed, and hopefully you notice it too, it's similar to the last ones. Well, this time the x value, they're all 0. So you look right there, that x value is 0, this one's 0, this one here is 0, and this one here as well is 0. So I'm going to scroll down and we're going to answer what is in common between each of the x-intercepts. Well, simply that they, sorry, these are the y-intercepts. So I'm going to change that. What isn't similar between each of the y-intercepts, it should say. And so that then would be the x values are always 0. So when we're finding the y-intercepts, the x values are 0. Just to recap, but for the y-intercepts here, the x values are 0. We just looked at that. And the x-intercepts, the y values are 0. But I kind of gave you a little ordered pair here. So for the x-intercepts, you're going to have a specific x value. Could be something other than 0, but the y is always 0. Over in the y-intercept, where it crosses the y-axis, the x is always 0. It's going to be on that y-axis somewhere, so it's going to be a different y maybe. But you never go over. It's just 0 for the x value. And that's important to know. So to write that down would be very useful, because what we're going to do next is going to use directly that. And we're going to just find the x and y intercepts from equations. Instead of looking at graphs, we're going to look at equations and find them. And if you follow along, it can be a quick process. And these 3 steps that I've written down right here are actually really, really nice, really useful. They're simple and very helpful. So finding the x-intercept. First, we're going to plug in 0 for y. And so that means y is 0. And why that makes sense is because what we just said before. If we're finding the x-intercept, the y value is always 0. So we'll use that. We'll use that y is 0. After you plug that in, you can solve for x. You'll get the x value, and then you put it in to find the x-intercept. It's going to be whatever that x value is, and 0. So we know at the end here, it's going to be the x-intercepts. X-intercept. I'm not sure how that happened. Would be, I'm sorry. All right, so that would be whatever our x value is and 0. So we just got to figure out what that x value is. All right. So we'll do that. Take a look at this equation. We have an equation, and following those steps, the first thing to do is to plug in 0 for y. So we're going to plug in 0 here. And when we plug that in, you need to know that this is 2 times y. You're not going to plug in 0 and this is going to turn into 20 because it's a 2 and a 0. That's 2 times y, so it's going to be 2 times 0. So in other words, when we plug it in, it'll be 6x plus 2 times 0 equals 18. And if you know anything about multiplying by 0, this whole thing is going to be 0. So it's going to be 6x plus 0. So I'm just going to cancel that out in green because 0 is just 0. If you add 0 to anything, it doesn't do anything. So we really just have 6x equals 18. And then step 2 says solve for x. Simple one-step equation. To get rid of this 6, you divide both sides by 6. You do it to the left side to cancel this out, and then you have to do it to the right side to keep it balanced. And you're left with x equals 18 divided by 6, which is 3. And we take that and put it right in here. So that's our last step. Put it in the order pair. So now that your x-intercept would be 3, 0. We can check back here. That's what it should be, right? The y value is 0 and whatever the x value is. So we got 3, 0 for our x-intercept. Now what we're going to do is we're going to find the y-intercept. The y-intercept is almost identical, only we know that the x value is 0 for this one. So this one we know that x equals 0. We can plug that in, solve for y, and then find our x-intercept, our y-intercept. Which would end up being 0 and whatever our y value is. So we'll figure that out. So let's first plug in 0 for x. And just like before, that would be 6 times 0, not 60 or 60. It's 6 times 0 plus 2y, which is 2 times y, equals 18. Which is really nice. This will cancel out because that's 0. 6 times 0 is 0. Then you're left with 2y equals 18. And since it's 2 times y, the inverse is division. So we'll divide by 2 to undo that. That cancels that out. And then divide by 2 over here. Y equals 9. And then we can use that, take that, and put it in here and find our y-intercept to be 0, 9. So we have our x-intercept, we have our y-intercept, and we're done. I wanted you to find the two intercepts. And what you could do there is if you wanted to draw the line for the equation then, you plot it. So we had 1, 2, 3, 4, negative 1, 2, 3, 4. Now this is just a rough sketch. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, all. So you plot those 2 points, which would be 3, 0, 1, 2, 3, up 0 or down 0. So that's 1 point. That's the x-intercept. The y-intercept is going to be 0, 9, which would be up here. And then you just take a ruler, draw a straight line through that, and there's a line of the graph. Just from that, you graphed an equation, which is pretty neat. All right. So what I'd like you to do on your own is to try this I want you to try the first two. I'm going to go through the second one real briefly, but I want you to try both of these examples. And I'll just check where we're at for time. If you want to pause it and try these, you can, but I'm going to go through I actually just went through one similar to number 2, so I'm going to go through number 1. Number 1 will be nice and quick. So following those steps for the x-intercept, what we're going to do is first plug in 0 for y. So that's x plus 0 equals 1, sorry, negative 1, or x equals negative 1. That was nice. We didn't have to do anything else to solve. So our x-intercept then would be negative 1, because the x is negative 1, and 0. We know the y value is going to be 0. There's the x-intercept. Now we'll, in green over here, do the y-intercept. We'll plug in 0 for x this time, so 0 plus y equals negative 1. And really that's just y equals negative 1, which is awesome, because then you can take the point 0, negative 1 to be your y-intercept. Again, if you want to graph those 2 points and draw the line straight through those, you've got the line for this equation. All right, so I hope you learned a thing or two. We focused on finding the intercepts from a graph and from an equation that is in standard form. Those are the two things that we worked on today, and I hope this video helped. Have a good one.